Hey guys, today we're going to talk about systems that have three variables. So previously we've dealt with systems that have two variables and we've had two equations for those two variables. Well, now that we have three variables, we are going to have three equations. So our first example looks like this. Our first equation is x plus y minus 2z, so z is our third variable, equals negative 9. Our next equation is 3x minus y plus z equals 13. And then our third equation, 2x plus y plus 4z equals 17. So the very first step is to choose what variable we want to eliminate. Okay, so I notice that y and negative y will cancel out, right? So I'm going to just, my choice, I get to pick what variable. I'm going to choose, right? I'm choosing. So I want to eliminate the y variable. I want to eliminate y, okay? So, what we do now is we will eliminate the y, right? So first we're going to pair up these two equations, the first two, to eliminate y, okay? So that becomes x plus y minus 2z equals negative 9, 3x minus y plus z equals 13, right? We add those together. We get 4x, our y's cancel. That becomes negative 2z plus z is negative z. And then negative 9 plus 13 becomes 4, right? So we get that equation. All right? So that came from doing the first two. All right? Now I'm going to take the second two and eliminate y again. Okay? So when I do the second two, I'm going to start with the second equation, 3x minus y plus z equals 13. And then the last equation, 2x plus y plus 4z equals 17. So I'm going to add those two up. Okay, so I get 5x, my y's cancel, z plus 4z becomes 5z, 13 plus 17 becomes 30. Correct? All right. So now I have two brand new equations, okay? Those two brand new equations are going to become my new system, okay? I just created a new system with only two variables, right? So from there, I'm going to decide, well, what can I eliminate? And so you pick x or z, right? Are we going to eliminate x or z? Okay? It's your choice what you want to eliminate, x or z. Okay? I'm going to choose to eliminate the z because I already have a negative and a positive, right? So from here, I want to eliminate z. Okay? So I have 4x minus z equals 4, and I have 5x plus 5z equals 30, right? That's my new system. 4x minus z equals 4, 5x plus 5z equals 30, okay? But if I want to eliminate z, I have to multiply my top by 5, so that way I have negative 5z, right? So my new system becomes 20x minus 5z equals 20, and then I end up with 5x plus 5z equals 30, okay? And I add those together. I get 25x, my z's cancel, equal 50. And now I can solve for x. Now I know that x is equal to 2, right? Because you divide both sides by 25. X is equal to 2. All right. So now that I know x is equal to 2, I want to plug in x 2 for x, any equation where all I have is an x variable and another variable. Okay, so that means one of these two equations, right? So let's pick this one, right? You can pick either one, you'll still get the right answer, but we're going to pick this one. So 4 times 2 minus z equals 4. So 8 minus z equals 4. So negative z equals 4 minus 8 is negative 4, which means that z is equal to 4. Now I have x figured out, and now I have z figured out. So my last step is to go back to the beginning. So now we have, from our 3 original equations, pick one, plug in x and z, and you'll be able to solve for y. So I'm going to choose my first one, okay? You could choose any of them, but I'm going to choose my first one. So x, which x is 2, plus y, minus 2 times z, which is 4, equals negative 9. Okay? So I have 2 plus y minus 8 equals negative 9. 2 minus 8, that becomes negative 6. I add 6 to both sides, and y is equal to negative 3. Okay? So I have an x, I have a y, I have a z. I do write it as an ordered pair, except for it has instead of having two parts of the ordered pair, I have 3 parts. So again, my first part is my x, so my 2, comma, now my y value, which was negative 3, comma, now my z value, which is 4. All right, so this is my answer, 2, comma, negative 3, comma, 4. Next example. Okay, so let's say I have a system that looks like this. X plus y equals 6. 3y minus 2z equals negative 10. And 4x plus 5z equals 56. Okay? What you can do here, you can choose to eliminate a variable if you want. But another thing that you can do is, if you notice, well, I know I have 3 variables going on, but my first equation, I can rewrite my first equation and figure out what y is in terms of x, right? So I can rewrite x plus y equals 6. That's really saying y is equal to 6 minus x. Okay, y is really 6 minus x. So you can do that for anything. You can also say, well, x is 6 minus y, okay? So again, you can take one equation and manipulate it to solve for one single variable. All right, so what we're going to do, now that we know that x plus y equals 6 is the same as saying y equals 6 minus x, well, I notice that I have a y in my second equation, so I'm going to substitute y equals 6 minus x into my second equation, okay? And that gives me 3 times, I'm going to substitute for y, so I'm going to say 6 minus x minus 2z equals negative 10, okay? So that becomes 3 times 6 is 18, minus 3x, minus 2z equals negative 10. Okay, let's go ahead and get our variables in order. So we're going to subtract 18 from both sides. So we get negative 3x minus 2z is equal to negative 28. Okay, so that becomes our new equation. Okay, well, I can take this new equation and now add it to my third equation, right? So I'm going to add it to my third equation. So I'm going to add 4x plus 5z equals 56 to my new equation, negative 3x minus 2z equals negative 28. Okay, however, before I do that, I want to make sure that something cancels. Let's cancel the z's, right? Let's cancel z. So in order to cancel z, I'm going to multiply this by 2 and multiply this by 5. So this becomes 8x plus 10z equals, double of 56 is 112. And then my second equation becomes negative 15x minus 10z equals the double of 5 times negative 28 becomes negative 140. Okay, when I add those together, 8 minus 15 becomes negative 7. My z's cancel. And then 112 minus 140 becomes negative 28, which means that x is equal to positive 4. All right, now that I have an x, I want to plug x equals 4 into an equation, okay, that has x and one other variable, which my first equation was x plus y equals 6, so that's a perfect equation, right? So 4 plus y equals 6, which means y is equal to 2, right? So now I have my x and my y. So now all I need to do is figure out z, okay? Let's go ahead and just use our second equation to solve for z. So 3 times 2 minus 2z equals negative 10. So 6 minus 2z equals negative 10. We subtract 6 from both sides. So negative 2z is equal to negative 16. So z is equal to positive 8, right? So now I've got my x, my y, and my z. I'm going to write that as an ordered pair. So x comes first. It was 4. Then my y, which was 2. And then my z, which was 8. So that would be my answer. All right. So that's how you deal with systems that have 3 variables. All right, thanks for watching.